So basically, the previous warm-up activity, the number 4 there, it was a sneak preview of the disk method and the washer method right here. Okay, and then our second objective has to do with finding the volume of a solid with known cross sections. So take a look here. We've got the rectangle shown is the base of the solid whose cross sections perpendicular to the y-axis are shapes indicated below. We're going to have squares, we're going to have equilateral triangles, we're going to have semicircles. These are the most commonly used ones. On the AP Calculus exam, it's entirely possible that you have something else, something that is very easy to find geometrically based on a particular side length or something like that. And that's why I'm saying squares, equilateral triangles, and semicircles. You could have rectangles, you could have trapezoids, but those three, most common. All right, so, and then we want to find the volume of each solid. And probably right now you're going like, what? What is this? How? What? Okay, so you have to think three-dimensionally. Okay, it's sort of like Marty McFly, who had trouble thinking fourth dimensionally, but here, you just take away a dimension. You know what? Wait a minute, why am I doing this? I have this thing pasted, right? Paste. Oh, yay. It's the same rectangles that was before. All right, but I don't need my y-axis being quite this long, so I'm going to get rid of some of it. Yeah, this is going to look good. And then I'll copy this one again. Yes, perfect. All right, let's copy this so I can, duplicate this 1,000 times. Now, for this first one, we're doing, I believe it was squares, square cross sections. Beep. So I'm going to take, let's say I'm going to take this red-ish color, and I'm going to draw in a representative rectangle. And this rectangle is perpendicular to the y-axis. You can see that, perpendicular to the y-axis, these cross sections are. Doop, 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 doop. Now, think of there being a z-axis coming out at us at whatever angle that you want it to. So what I'm going to do is I'm going to take this as the base of a cross-sectional square. Actually, it's going to be kind of like a square prism, right? And maybe what I do is I'm just going to draw this thing straight up over here, come over. It's going to be in perspective, so it's not going to look exactly like a square, right? Of course. And then come straight over. Boop. This is looking pretty good until I just ruined it right there, and then ruined it again. All right, like something like that, and then dash this in. Can you visualize that, right? We have ourselves a square piece, a cross section that's coming out at us at another axis here. What three-dimensional shape is that basically going to make? I do believe that this is going to make ourselves a square prism. So it'll look like this. Do you remember how to draw a square prism? You start with a square. Look how square this is, right? And then maybe an offset another square in the background here. And then you connect the corresponding vertices. Believe it or not, this is an enlarged version of what the heck is going on right here. And here is your purple base shape down here. Yeah. Right? Okay, and then if you want me to, if you ask nicely, what I'll do is I'll also draw in our representative rectangular shape. Right? It would have been, ooh, yep, there we go. It would have been like right down here. All right, here's our representative rectangle. And then, I can finish this thing off sort of like that. That looks like garbage. Let me try again. All right, so maybe I'll come over here first. Oh yeah, this is looking way better. All right, so here, and then there, and then, oh, I can see what the problem was. The problem was I didn't quite draw this thing straight. But anyway, you see that cross-sectional shape that's right there? Yeah, maybe it also gets some shading. Sort of like this, and then like this guy. Oh yeah. Okay, this is like a textbook perfect illustration. Go ahead, copy, paste it, take a screenshot. Looks gorgeous. All right, what did we want to find about this? I mean, there was a point to it, the whole thing. We wanted to find the volume. So the volume, this is a rectangular prism. So what I do is basically I find I said rectangular prism, square prism, same thing really. Find the area of the base, and that base is the exact same thing as the area of this cross-sectional piece that's right here, which I'll just call big B, and then multiply that thing times the height. And the height, where are you going? Is going to be our height. And our height is this piece of our rectangle for this one, which a height of 6, I do believe. Multiply it times our height, area of our base. Well, I need, since we're talking about the area of a square, I need its side length. And this side length, of course, is 3, right? And it's a square. So we square that thing. And it just turned into a cube for whatever reason. We got 9. So we have 9 times 6. We have 54 units cubed. There you go. All right. Let's see what else we got. We got the same exact kind of setup at this time with equilateral triangles. All right, let's do our fancy copy and paste feature here, and then equilateral triangles. All right, and then let's draw in the representative rectangle just like I did before without erasing stuff. Here and here. Doop, 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 doop. Okay, once again, think of like there being a z-axis coming out at us, and then in perspective kind of view, we're going to draw ourselves an equilateral triangle. You'll just have to use your imagination that is actually equilateral. But here's what it will basically look like. It's going to make, in this case, an equilateral triangular prism like this. Draw an equilateral triangle. And another one kind of in the background here. And then connect the corresponding vertices. I don't know what the heck is going on with that edge there. Oh my god, that looks terrible. Let me try that again. Okay, so maybe if I offset them a little bit more, it'll look more convincing. Okay. 20 minutes later, he actually draws a rough approximation of a triangular prism. Look at this. Look how shaky those lines are. It's like I'm nervous about something. All right, and the color in the base here. That is the rectangular base, the same rectangular base we started the whole entire thing with. Voila. Yes. Okay. And then with your red crayon, here is our representative rectangle. Right. So, right, it's this guy here. And then you can see this time, here is our slice. Cross-sectional slice, which does make another equilateral triangle. Just go with it. Okay, and then, you know, if you wanted some additional shading on that, I will accommodate you. Okay, all right, yeah. There we go. Now I can see it. Perfect. All right, so again, exactly like it was before, it is prismatic. To find the volume of a prism, it's the area of the base times the height, and this base is the same thing as this area piece of this cross-sectional piece, right? So I will find volume as big B times H. Okay, it's at this point, height is equal to 6 again. It is at this point that we definitely need to take a moment to derive a formula that you should have memorized honestly, or at least understand how to come up with this formula for an equilateral triangle area. It's going to come up so often. So area of an equilateral Did I even spell that right? Triangle. Geez, as a geometry teacher. Now, I could just give you the formula. The problem is, in the heat of the moment, let's say, for example, that you are taking your AP Calculus exam, just imagine, if you will, and then you don't remember what the formula is because nobody taught you where it came from. That's my goal right here. So if you understand where it comes from, easy to remember, and then also, if you needed to, you could just come up with it. Okay, so I have an equilateral triangle, as you can clearly see here. All the sides are the same. I'm just going to call it S, right? It's this S, this fancy S shape here. And any triangle's area would be 1/2 base length times the height. And we already have a base length. Our base length is a side length that's down here. And our heights, let me just go ahead and draw this thing in. Here's our height there. And notice that it does trace off a right triangle over here. And specifically, if you remember from geometry, this makes a 30, 60, 90 right triangle. Here's our 60 degrees. Here's our 30-degree angle. And in order to find all of the pieces, you only need one. And I'm just going to use this hypotenuse. Here's S. That means this small piece down here is 1/2 of S. And then the hypotenuse is going to be this multiplied times the square root of 3. Here, where's the eraser? Okay, so I will write that as the square root of 3 over 2 times S. All right, we're ready to go. 1/2 base length, original base length was S, times our height. Our height, we just said, is the root 3 over 2 times S also. Okay, and then multiplying all of this stuff together, 1 times the square root of 3, I'll have a square root of 3 on top, 2 times 2, I'll have a 4 on the bottom, root 3 over 4, and then S times S gives us an S squared. So notice that this is basically the area of a square, side squared, and then you have this kind of scalar scale factor that's right here, which is the square root of 3 over 4. All right, have that thing memorized. Maybe we should put that on the memory card. I don't know, that's actually not a bad idea. Something for next year. Okay, so I've got area of my base then is going to be root 3 over 4 times our side length. Our side length is the same 3 that we had before, multiplied times 3, which is squared. Okay, and then we're going to multiply it times our height, and our height is 6. All right, let's do some calculation here. Root 3 over 4, that's a 9, that is 54. Actually, you know what I'm going to do instead? I'm just going to cancel out some stuff. Here, a 2, a 3, that makes 27, right? I think 27, not a 3, how about a 2? Yeah, which, you know, if you wanted to rewrite it to make it look pretty, 27 root 3 over 2 units cubed. One more. We have ourselves semicircles. So I'm responding to all of those people who basically have been begging me to make videos much, much longer. You know, I really, really like it when your videos are at least 30 minutes long each. Where's my paste? Come on, did that not paste? Paste. Yay, there we go. All right, and this one's going to be semicircles. This one is the one that I have kind of the hardest time drawing the semicircular little pieces. Let's see how I do. All right, so representative rectangle once again, and then I'm going to draw some semicircular pieces here so it'll look sort of like that. Oh, there we go with that kind of nervous line. Can you visualize that? What shape is that thing going to make? So think of these things as being cross sections that repeat from bottom to top here. It is going to make basically a half of a cylinder. It should be this color. Okay, so I'm just gonna make it again prismatic, sort of like this, and then another one back here. Perfect. All right, anyway, so connect this guy, connect this here, and then you're gonna have sort of like this edge that's right there. Oh, yes. Yes, indeed. All right, let's get some crayons going. Here's our rectangular base. And you can almost hear SpongeBob playing in the background where it goes like 3 hours later. Anyway, and then here's our rectangle, our representative rectangle. Yep, 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 yep. And then, yeah, so here's the part that's going to be kind of awkward. Oh my God, yes, that's terrible. Well, it was looking good until I messed this part up, but yeah, that's supposed to be a semicircular cross section. Okay, anyway, how do I find the volume of this thing? Well, if it was a cylinder, you'd take the area of the cylindrical base and you multiply that thing times the height. Well, it works the same exact way with these cross sections, which are semicircles. You're just going to find the area of this semicircular base, which is the same thing as a semicircular cross section, which we'll again just call B, multiplied times height. And the area of B this time is just half of a circle, which is 1/2 pi r squared, or, if you wanted to, pi over 2 times your radius squared times your height. And that, notice that this is basically, it's just, again, it's like a square that's being scaled by something. All right, now then, this is where it's a little bit different. Since we're doing semicircles, we want a radius. This whole entire length here would be 6, so our radius this time is like 1.5. Does that make sense? Hopefully it does, which we will square pi over 2, 1.5 squared multiplied times our height, and our height was 6, and then we can do some cancellation as we did before. Now, let's see, what do we got? We got a 3 there. Say 15 squared would be 225, so 2.25. And then 2.25 times our 3 gives us 675. And then don't forget your little pi, and then your units cubed. And we're done.